In this video, they want us to find the area of the rectangle. So the rectangle is ABCD. And inside this rectangle, we have 3 identical circles of radius, each of radius 1. Okay? So all these 3 circles are tangent to each other. So as you can see, this is tangent to this at this point, and also this one is tangent to this one at this point. And they have collinear centers. So these centers are collinear. And also the outer 2 circles, as you can see, are tangent to the 2 sides of the rectangle. So this circle is tangent to the rectangle at this point and at this point, while this circle is tangent to the rectangle at this point and at this point. Now the diagonal of the rectangle, which is AC, this diagonal is tangent to the 2 outer circles. So as you can see, it's tangent to this first outer circle and also tangent to this third outer circle. And this diagonal AC passes through the center of the middle circle, as you can see here. So this line AC is passing through the center of this middle circle. Now let this point here be E. Let this one here be F. Let this one here be G. And let this center be H. And let this center of this one be I. And let this one here be J. The first step we're going to do is we're going to connect center H to center I, and also connect center H to point of tangency F, just like I have done here. So we can see that this angle here is 90 degrees due to the tangent to a circle theorem, where the radius of a circle and the tangent form an angle of 90 degrees between them. So this is 90 degrees. As you can see, HF is radius of this circle, and we're told that radius is 1. So this is 1. Now, for HI combines the radius of this first circle and the radius of this second circle. So HI will be 1 plus 1, which is 2. So HI is 2. So since we have this side, and remember that this is a right triangle, let us use Pythagoras theorem to find Fi, length Fi. So in triangle HFI, using Pythagoras, a squared plus b squared is equals to c squared. And our a is Fi, so Fi squared plus our b is 1 is equals to our c, which is 2. So 2 squared. So Fi squared plus 1 is equals to, this gives us 4. Take 1 the other side, we shall have Fi squared being equals to 4 minus 1. And so Fi squared is equals to, this is I. Don't confuse it for 1. So Fi squared will be equals to 3. To get rid of the square, we find the square root on both sides. And so our value of Fi is root 3. Therefore, from here to here is root 3. Now, since we've got Fi as root 3, that implies that also this length Ij is also root 3. Now, this segment gc is congruent to the segment AF here. This segment AF is congruent to segment gc by symmetry. Okay? And the two triangles DAC and triangle BCA are congruent by side angle side congruence. Due to the definition of a rectangle, the two opposite sides are equal and all the internal angles are 90 degrees. So this triangle DAC is congruent to triangle BCA. And also, these three circles are congruent and identically placed within these two triangles, this one and this one here. Okay, so the circles are identically placed relative to the two triangles formed by this rectangle. So it turns out that this figure is symmetrical along the diagonal AC. Okay, so AC is the line of symmetry for this rectangle, and so the whole figure is symmetrical around AC. Along AC. Now we know that two tangent lines from a circle that meet at a point are equal. Okay, so that implies that AE is equals to AF. So let us call it B. So AE is B and AF is also equals to B. And also we can see these two segments GC and FC are all tangents to this circle, and they meet at this point C. That implies that GC is equals to FC. Let them be A. So GC is A and also FC is also A. Now since FC is equals to A, that implies that, so our A is equals to FC, which is equals to Fi plus Ij plus Jc. Okay, and so our value of A is equals to Fi is root 3 plus Ij is also root 3 plus Jc. We said Jc is congruent to AF, and our AF is B. So this will be plus B. And so A is equals to this plus this gives us 2 root 3 plus B. Let this be equation 1. Now diagonal SC is equals to CF is equals to AF plus FC. And our AF is B plus our FC is the same as GC, which is A. So plus A. And then line AD is equals to, this is AE plus ED. So AE is B plus ED. So if we were to draw a line here, that implies that if we, from this point to this point is radius of this circle, which is 1. And from here to here is equals to from here to here. So ED is 1. So AD is equals to B plus 1. And then CD is equals to CG plus GD. So CG is A plus, now this ED is equals to DG because they are segments to, and they are tangent to a circle and they meet at this point. So ED is 1, also GD is 1, and it's equal to the radius, so it's 1. So CD is equals to A plus 1. Now if we are to consider triangle ACD, which is like this. So this is D, this is A, and this is C. This side, AD, we said is B plus 1. this side DC is a plus 1, this, and this hypotenuse AC, we got it as B plus A. So since it's a right triangle, using Pythagoras theorem, shall have A squared plus B squared being equals to C squared. Our A is A plus 1, so A plus 1 squared plus our B is B plus 1, so B plus 1 squared is equals to our C, which is A plus B or B plus A, so A plus B squared. So when we expand this here, we shall have A squared plus 2A plus 1, then this one we shall have plus B squared plus 2B plus 1 is equals to, then this here will be A squared plus 2AB plus B squared. As you can see, we have A squared here, A squared, they cancel out, and also B squared, they cancel out. So we are left with 2A plus 2B, then we have 1 plus 1 is 2, so plus 2 is equals to 2AB. Let us divide the whole equation by 2. So this by 2, by 2, by 2, by 2. So we shall have A plus B plus 1 being equals to AB. So let us take the A to the other side. We shall have B plus 1 being equals to AB minus A. And so B plus 1 is equals to, we factor out A, shall have B minus 1. Now remember, from equation 1, we had A being equals to 2 root 3 plus B. So we are going to substitute this value of A here. So we shall have B plus 1 being equals to 2 root 3 plus B into B minus 1. So we shall have B plus 1 being equals to, when we expand this, we shall have 2 root 3b minus 2 root 3 plus b squared minus b. So we have b plus 1 being equals to b squared plus 2 root 3b minus b minus 2 root 3. So we take this side, we shall have b squared plus 2 root 3b minus b minus b minus 2 root 3 minus 1 is equals to 0. So we have b squared plus 2 root 3b minus, this gives us minus 2b minus 2 root 3 minus 1 is equals to 0. So we write it in form of a quadratic equation. So we shall have b squared plus 2 root 3 minus 2, we factor out b, so into b, then minus 2 root 3 plus 1. This is equals to 0. So let us solve this quadratic equation. Let us calculate the discriminant. So we're going to, our A value is 1, our B, which is not this B, so B is the value for the constant value, the value for B, not implying this B. So B is this here, 2 root 3 minus 2, and C is this one, negative 2 root 3 plus 1. So we're going to substitute these values into the discriminant formula, which is D is equals to B squared minus 4AC. So D will be equals to, B is 2 root 3 minus 2, so this is squared, minus 4 into 1 into C is negative into 2 root 3 plus 1. So let us expand them. So we shall have D being equals to, when we expand this one here, we get 12 minus 8 root 3 plus 4. Then this one here, when we expand it, we get plus 8 root 3 plus 4. So D is equals to, shall have 16. So 12 plus 4 is 16 minus 8 root 3, then plus 8 root 3 plus 4. So D is equals to, so minus 8 root 3 plus 8 root 3, these cancel out. So we have we have positive 16 plus 4, which is 20. So the discriminant is 20. So next, let us apply the quadratic formula. So B will be equals to minus B. Note that this B is different. This is the unknown, and this is the coefficient of B. So minus B plus or minus B squared minus 4AC over 2A. But remember, we have determined the discriminant. So this B will be equals to minus B plus or minus root of discriminant over 2A. So we're going to solve this. So B is equals to minus, our value of B is 2 root 3 minus 2. Then plus or minus, we've got our D as 20, so root 20 over 2 times 1. So B is equals to, open brackets here, we shall have minus 2 root 3 plus 2 plus or minus root 20 is the same as 4 times root of 4 times 5 over 2. So B is equals to minus 2 root 3 plus 2 plus or minus, this gives us 2 root 5 over 2. And so B is equals to, when you divide by 2, since they're all divisible by 2, we shall have minus root 3 plus 1 plus or minus root 5. So B will be equals to 1 minus root 3 plus or minus root 5. Now I'm only going to consider the positive here, and therefore B is equals to 1 minus root 3 plus root 5. So this is our value of B. Now let us recall that A is equals to 2 root 3 plus B, and we've got our value of B, so we're going to substitute. So A is equals to 2 root 3 plus 1 minus root 3 plus root 5, and therefore A is equals to, so shall have 1 plus, so 2 root 3 minus root 3 leaves us with just root 3, then plus root 5. So this is our value of A, and this is our value of B. Next is, now we have to find the area of the rectangle. So the length, which is DC, is, so DC, remember this is 1, it's equals to the radius, so 1 plus A, which is A plus 1, okay? and the width AD is equals to B plus 1. So we have the length and width. So area is equals to length times width. And so area will be equals to, our length is A plus 1 and our width is B plus 1. We already have the value of A and the value of B. So we're going to substitute. So area A will be equals to, A is 1 plus root 3 plus root 5, then plus this one, then into B is 1 minus root 3 plus root 5, then plus this one. Okay, so A is equals to 1 plus 1 is 2, so 2 plus root 3 plus root 5 into 1 plus 1 is 2 minus root 3 plus root 5. Now we know that from A plus B into A minus B being equals to A squared minus B squared. So let us rearrange this so that we shall be able to get something like this. So our area A is equals to 2 plus root 5, then plus root 3, then this one 2 plus root 5 minus root 3. So now this is acting as our A and this is B. A and this is B. So this will be equals to 2 plus root 5 squared minus our B, which is root 3 squared. So A will be equals to, when you expand this, you get 2 squared plus 2 into root 5 plus root 5 squared. Then this cancels with a square root and we have minus 3. Okay, so area is equals to 2 squared is 4, so 4 plus 2 times 2 is 4, so 4 root 5 plus this cancels, so we have 5 minus 3. And so A is equals to 4 plus 5 is 9. So we have 9. So 9 minus 3 is 6. So we have 6 plus 4 root 5, which is equals to 14.944. So this is the area of the rectangle ABCD in square units. So hope you enjoyed the video. If you did, kindly give it a thumbs up. If you have alternative approaches, you can also share them in the comment section down below. Otherwise, thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment and share your thoughts in the comment section down below. Do not forget to subscribe. It's completely free of charge. Thank you. Let's meet in the next video. Bye.